All right, thank you so much. So, as mentioned, my name is Simon Indrele. I'm an application engineer for the manufacturing solutions team here at Computer Aided Technology. Before we jump into the presentation, let me just do a quick little overview of just what CATI offers. So, we offer design tools such as SolidWorks, simulation and analysis tools, technical documentation and publishing tools, printing and 3D scanning equipment and services, PLM and PDM management solutions, rule-based design automation, engineering workstations, and all sorts of services such as training, support, and consulting. So we have over 27 years as a product development solutions provider. We're the first SolidWorks reseller in all of North America. We're certified PDM service partner and all these things that you see here. So we have a broad industry experience, including but not limited to, industrial equipment, automotive, consumer products, aerospace, defense, life sciences, and so on. So with over 30 plus offices across the country in 30 different states, we are the largest value add reseller in North America for both SolidWorks and Stratasys products. So now let's go ahead and get going with our main topic, prototypes that promote. So what we're looking at here is a simplified product life cycle showing revenue over time. So you have your initial development cost of concept, design, test, focus group, and so on. And then no profits are received until the product is actually released. And then now begins the selling and the revenue that continue until the product is either obsolete or competitors enter that same market. But profits are still not realized until the break-even point after recouping your development costs. So now, what if we could improve our development time and cost? So 3D printing averages a 40% reduction in overall development cost and time. Faster development and first to market can capture significant market share. This yields better margins with more product sold before the effect of competition and obsolescence can be felt. And profits are also increased with a lower break-even line. It is important to note that as each phase of production progresses, cost and increases. Therefore, communicating and investing in the earlier stages can be most effective in saving time and money in the development cycle of the consumer market. So let's look first at some examples of just how 3D printing is being used by said consumer market. So CAD, or Center for Advanced Design, is a firm of design engineers specializing in creating complex surface geometry for the plastics industry. CAD's goal is saving time and avoiding mistakes, both of which saves money. They're using the Stratasys F370 to quickly make design changes and often print multiple iterations before any tooling cost is incurred. See their motocross helmet, which is designed to attach a GoPro camera to the visor. OtterBox is the #1 supplier of smartphone cases in the US. Their challenge is keeping up with the latest versions in the cell phone market. To keep up with the ever-changing consumer items, OtterBox uses the J750 3D printer to create the exact size, shape, and color of their designs. Prototypes went from days to hours, enabling a 67% time to market savings. Brooks Running is a US-based footwear company using a Connex 3 PolyJet printer to validate design at half of the time. This increased pace saves $500 to $800 per shoe design. In the photo, you can see two shoes that look similar, but with different tread designs. 3D printing lets them evaluate multiple iterations very quickly. Synergy is an R&D center for product development that specializes in consumer products, providing industrial design, engineering, and rapid prototyping services. The J750 meets all their needs of touch, feel, ergonomics, and environmental testing. Multiple machine operations are eliminated from 2 weeks to a few hours with a cost savings of 70%. Shown in the picture is the design for an automatic crash response system that can be customized for the car interior or customer preference. Let's look at a quick video of that.
Synergy is the R&D center for product development, industrial design services, engineer services, and rapid prototyping services. We specialize in a consumer product. We really understand the process from the initial sketches to design to production. Each stage, we understand exactly what needs to be involved. The competition in product development and product design is very high today. To sell a consumer product, you need to be very smart on one hand, but the other hand, you need to be very, very creative. The first time that entrepreneur sees idea and feel it in his hand, it is a crucial moment. We need to give him the most realistic prototype. Basically, to build a prototype like this takes a lot of time and a lot of subcontractors. And today, with the Stratasys J750, you can do everything on the spot.
We designed an automatic crash response system, which is actually this control panel. Now, when I come to design a new product, I have total freedom. I can take a CAD file from SolidWorks, for example, just throw the texture in there and the graphics, and I know that in a few hours I will get a prototype that I can touch and feel, even translucent materials if I want to create light transfer, to see a LED behind the screen with a soft touch, with rubber feel.
Even to show the electronic engineer how the circuit is going to be implemented inside. This allows my customers to take very accurate decisions about the future of the product.
We can combine from each department and assemble it together in one machine with no extra cost, with no extra effort, on the same tray overnight for different clients, and everybody's happy. They don't believe that this is coming out with full colors, full textures, full gradient. It's a game changer.
The J750 is a breakthrough solution in product realism. It's also very efficient and very versatile.
All right. So InnoDesign was founded in Silicon Valley in 1986 and is known for adding unique touches to the designs of major consumer customers across the globe, such as LG Electronics, Samsung, and more. Here, they use their J750 printer to print a full-color ribbon candy style headphone. This innovative model has won several design awards. Toy State International launches more than 200 new toys each year aimed at preschoolers, young children, and hobbyists. Designing the drone shown here was 25% faster, allowing more time to tackle more complex designs. The Stratasys F370 allows them to use materials that are similar to their end-use product, and the ease of use allows it to be incorporated into an engineer's daily routine. Smoby Toys have products ranging from bath toys and toys that encourage motor skills to outdoor slides, playhouses, tricycles, and more. The demand for new designs keeps Smoby's FDM 3D printer running more than 18 hours every single day. Printing parts with the Stratasys F370 allows them to have a tactile feel of the design rather than just a screen view on a computer monitor, and still accelerate development by 50%. In this picture, you see a smaller FDM prototype that stands in front of the final full-size outdoor playhouse. Thermos is an iconic brand producing insulated food and beverage containers. They maintain leadership by continually improving weight and usability. Thermos uses both FDM and polyjet technologies to create highly tactile prototypes in just minutes or hours instead of the 3 to 5 days they typically used to take. This produces a significant cost savings of 80% in their development cycle. Unilever is an international consumer goods company producing food, beverage, cleaning agents, and personal care products. Their Connex polyjet is used to make plastic injection molds to create short-run test parts out of the final molding material. Prototype costs are decreased by 20%, and design changes are 50% faster, with an overall design cycle reduction of almost 40%. So these are just a few of Stratasys' consumer customers. Chances are extremely good that you have already used at least one of their products this morning that was developed using 3D printing. So as you can see, Stratasys is the expert that the experts trust. So how does Stratasys become the expert? By creating a portfolio of equipment and materials that meet the needs of experts, let's talk about the two Stratasys technologies that make everything possible, starting with FDM. So Stratasys invented the FDM, or fused deposition modeling technology, in the late 1980s. FDM remains the most common method of 3D printing today for both hobbyists and industrial use. FDM takes heated thermoplastic filament and extrudes it layer by layer to create a three-dimensional part. Stratasys uses two print heads with two different materials. One print head is dedicated to the model material, while the other has a support material. Most hobbyist machines use the same material for model and support, making it difficult to separate support from the finished part. Stratasys often uses dissolvable support material to make it even easier and faster to get the finished model you need. FDM machines can build in 5,000s, 7,000s, 10,000s, 13,000s, or even 20,000 inch layers, depending on the material and the machine. If you need good detail, 5,000th layer will do the job. And if you need your model quick, 20,000th layers will meet your need for speed. So the shared office series is made up of the F123 series with different build envelope sizes and material options. The production series increases build size as well as material options. All FDM machines use GrabCAD print software to prepare jobs, while the F370 and above can also use Insight Advanced software to control each layer individually. Looking at FDM materials, let's start with thermoplastic elastomer. Stratasys offers a TPU with a 92 short A value. For automotive use, such as protective rubber boots or texture cover for a brake pedal, all can be built for design verification without investing in any tooling. There's a wide range of standard plastics, ABS being the most common in the industry. ABS with ESD, electrostatic dissipative, can be useful for electronics. Shown here is an ABS ESD7 made of carbon nanotubes blended with our ABS plastic, making it static dissipative and prevents a buildup of static electricity. With engineered plastics, Stratasys offers resilient polycarbonate with PC blends and a couple of nylon choices. Shown here are a couple of samples in the consumer market. A PC ABS saw handle and a nylon 12 battery box. Also new to the lineup is Duran with mechanical properties of Delrin, now available on the Stratasys F370. Delrin is mostly used in tooling applications for its dimensional stability, lubricity for wear resistance, and non-marring surface texture. High-performance materials include Ultem for high-temperature applications, Antero with PEKK, polyether ketone, for high chemical resistance, and Nylon 12 carbon-filled material for extraordinary strength properties. Utah Trikes, for example, uses Nylon 12 carbon-filled to customize their products. Nylon 12 CF is the highest strength-to-weight ratio material that we have available. And lastly, Stratasys specialty materials offer custom colors, certified grade, and the soluble ST130 material. Shown here is a rolling pin made of Ultem 1010 certified grade. The certified grade version of this material is approved for food contact with NSF 51 and biocompatible with ISO 10993 and USP Class 6 certifications. Now let's take a quick look at PolyJet. If you have an inkjet printer at home, you may be more familiar with PolyJet technology than you think. PolyJet uses the same kind of print heads that your home printer would use. The two differences in that Stratasys is that Stratasys incorporates a Z-axis, so the ink could be built up layer by layer, and they also use a specialty photopolymer ink. Photopolymer materials are hardened with UV or ultraviolet light. Like FDM, PolyJet technology also uses a separate soluble support material that allows you to just wash away the support material from your model. Models can be printed from 36 micron layer thickness for draft mode all the way down to 14 microns, or less than 0.5 of an inch, depending on machine and material combinations. The Easy Concept model series is made up of machines that can run several materials, but they do not support the mixing of materials for mechanical properties or blending materials to create different shades of color. When you move up to the Connex 3 machines, now you can mix up to 3 model materials to define specific colors or to create different mechanical properties. Moving up to the new Stratasys J835 and J850 printers that are loaded with 8 different materials, including the support material, will yield more than 500,000 colors and blending of multiple materials for specific mechanical properties. In addition, almost 2,000 colors have been Pantone certified. And now introducing, we have a new digital anatomy printer specifically made for the medical industry with new materials for medical realism. Most machines use GrabCAD print software to prepare jobs just like the FDM technology, minimizing a learning curve to own both technologies. Let's take a quick video about the Stratasys J850. So the J850 is our flagship full-color machine that is capable of large parts and long unattended runtimes. But for a while now, we have had smaller companies and design studios asking for similar capabilities, creating photorealistic prototypes quickly and inexpensively with a machine that's quiet and has a small enough footprint to fit in their design studio. And for those people, Stratasys has created the J55, a small footprint machine capable of printing surprisingly large parts due to its innovative rotating platform design. Let's take a quick look at that machine. So now that we've taken a look at some of the machines, let's look at the PolyJet materials that make these models possible. The Vero family is the starting place for materials within the PolyJet technology. The Vero family offers a wide range of vivid, transparent, or solid colors. Here are a couple consumer examples with a water bottle using the Vero Vivid material, showing semi-transparent color, and also a shoe model, entirely 3D printed to simulate color, shading, and texture. Next in the material portfolio are the flexible materials. Agilis 30 with a Shure 30A durometer is the second generation of the flexible material and has significantly better strength than the previous Tango material. The flexible materials can be blended with other materials to modify the durometer ranges. from 35 to 95 on the short A scale. So simulating the overmolded edges of a GPS concept model or the flexibility of a food container lid are all achievable. Here's a quick video about Agilus 30.
Creating 3D printed parts or prototypes with simulated rubber isn't a nice to have, it's a must have for designers and engineers, particularly if your prototypes are for applications in industries such as consumer goods, consumer electronics, automotive and medical devices. So this is the new Agilus 30 rubber-like material family from Stratasys. It's available in black and translucent. And it provides superior tear resistance of up to 6 to 8 kilograms per centimeter, elongation of break of up to 220 to 240%, and tensile strength of up to 2.4 to 3.1 megapascal, which makes it ideal for prototyping delicate designs or parts that undergo repeated flexing and bending. The material features an improved surface texture that's not only easier to clean, but also looks and feels more like rubber. And of course, because it's polyjet technology, you can create a whole range of digital materials with differing short A values, shades, and colors. So here's the Agilus 30 combined with digital ABS material for simulating tough parts with rubber surrounds, overmolding, and really good non-slip surfaces. Or you can combine it with the rigger material to create these living hinges and polypropylene-like performance. Also, you can use it with Virocyan, magenta, or yellow to produce a whole range of digital materials with flexible colors and textures such as these. So if you need professional prototypes that stand up to all your design verification requirements, the Agilus 30 family is the material choice for all-round rubber-like performance. Thanks for watching. See you next time.
Next is the Veriflex material, specifically made for the consumer eyeglass industry. Veriflex is stiffer than the 30 to 95 short A range available with the Agilus family, but still more flexible than the Vero family. For the medical market, we have offered biocompatible and dental materials for quite a while, but new is the bone matrix, tissue matrix, and gel matrix materials exclusively for the new digital printer. These materials have specific build parameters to create the structure, texture, and feel for anatomical simulation and diagnostics. Specialty materials include high-temperature photopolymer and a digital ABS. The plastic injection shown here is made with digital ABS and shot with a polystyrene material. Plastic injection molds can be a tool for development, short-run production quantities, and even bridge tooling for production until high-volume tools become available. And lastly, let's take a quick look at some of the features that the GrabCAD print software that runs these machines is capable of. So it works with most FDM and PolyJet equipment that Stratasys offers. It can import native CAD files, so whether you're working with SolidWorks, CATIA, Inventor, etc. If you're familiar with the 3D printing process and you're very constantly converting files to STL, you no longer need to do that. You can correct or repair any mesh problems if you're importing mesh files. You can estimate material usage and build times. You can manage assemblies, separate or group. So if you have a SolidWorks assembly, for example, you can just import that whole assembly. You can ask the software to break the assembly down and just place all those individual parts on the tray, or you can ask for it to remain an assembly. You can select PolyJet colors and durometers. So if you're interested in assigning Pantone colors to a logo or something like that, all that can be done in that software. You can select the FDM build styles, support angles, and more. So whether you want the part to be solid or you may want it to have a sparse infill to create a lightweight part. And then we have advanced FDM setting parameters that'll actually allow you to control those kinds of settings, whether a part is solid or sparse, depending on different parts, different features within the part. So if you have a section of a part that really is seeing a lot of load and it's breaking, you would like that solid. but it would be wasteful to print the whole part solid. Advanced FDM can do that for you. And then we also have Insight Advanced software that can be launched from within GrabCAD, which will give you individual advanced control over the FDM toolpaths. And that concludes our presentation.